Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and this is the ninth and final video on sequences and series, and we're going to be talking about sigma notation. Right, so in this particular video, I'm going to introduce you to a slightly different notation for the summing series that you may not have seen before. It's really straightforward, it's just a bit of notation. Now and again an exam question comes up using it, and I'm going to go through 3 examples that show the style of questions that come up. Okay, what's this whole thing about sigma notation? Mathematicians are lazy, and they like writing out sums and various things in quicker ways. Let me try and show you what I mean. Imagine I was doing 1 plus 2 plus 3 plus 4 all the way up to plus 99 plus 100. i.e. I'm adding all the numbers, the positive numbers from 1 to 100. They get bored writing that out, and they have a way of writing out. This is how they write it. They know that any number, any whole number can be represented by, let's say, the letter R, right? Let's check they're doing that in this. Yeah, the letter R. And they say, I'm going to sum. That sign means to sum. So that's sigma. That is the Greek symbol sigma, and it means sum, to sum up. I'm going to sum all the numbers, but when R started off being the number 1, and it ended up being R is 100. So I'm going to sum all those numbers. When R is 1 plus R is 2 plus R is 3 plus R is 4 up to R is 100. And they even take one more of a shortcut. They don't bother writing R is 100 on top. They write the sum from R is 1 to 100 of R. And that means 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now, how would they do something like this sum? 2 add 4 add 6 add 8 plus all the way up to plus 198 plus 200. These are the even numbers, and you can write a formula for the even numbers as 2r, can't you? 2r. Any even number can be written as 2 multiplied by a whole number, and they would sum these. Now you just have to be careful here. What's r in the first instance? Well, r is 1, because when I put 1 in here, 2 times 1 is 2. When I put r is 2 in here, 2 times 2 is 4. When I put 3 in here, when r is 3, 2 times 3 is 6. So this is nicely checking off these numbers. Now be careful, r doesn't go up to 200. Think about it. If I put r as 200 in there, 2 times 200 would be 400, not what we want. R actually goes up to 100, doesn't it? Again, because 2 times 100 would give me the 200. And 2 times, let's say, 99 would give me the 198. Okay, so that's a basic idea of sigma notation. Now, I'm going to do 3 examples that hopefully make this make a bit more sense to you. Let's start off. Firstly, sometimes what they might do is they might write out a series, sum of various numbers in a sequence, and they might ask you to write it in sigma notation. So let's think about this. What we would like to work out is the nth term of that sequence, okay? So we know that any sequence, the 2, the 5, the 8, the 11, the blah, 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 we can write that as un is equal to a plus n subtract 1d. We know that's the formula for the nth term of a sequence. A in this case is 2, d is going up in 3. Now, we don't necessarily, and we don't know n, but we don't need to know n. So let's state that un is therefore 2 plus n minus 1 multiplied by d, which is 3, I'll write it there, and tidy it up. Un is therefore 2 plus 3n take away 3, therefore un is equal to 3n take away 1. Now that's the nth term of a sequence, right? So I could write this in sigma notation. I could say what we are summing up, I could use Rn. Let's just stick with n because it's here, but I could also use ur, it's 3r minus 1. I could say I'm summing every term in the sequence here, which can be written in the form 3n take away 1. And n is starting off at 1, because when I put 1 in, 3 times 1 is 3, take away 1 is 2. So I'm certainly starting at 1, but what am I going up to? Well, what n will give me 89? Well, n is 30, I think you can see. If I put 30 in, 3 times 30 is 90, take away 1 will give me the 89. So I'm summing that from 1 to 30. And that is what I'm summing. Now I could have written it with R's as well, because sometimes mathematicians with sigma notation, they use R. The exact same thing, it doesn't matter what letter you use, that could be R is 1 to 30 of 3R minus 1, it's the same thing. But the first thing we needed to do is work out the nth term, or the general term of a sequence, and then sum it and find the number we start at for our N or R and the number we end at for our N or R. Example 2. Sometimes they give you the sigma notation and they ask you to work it out. This is quite easy. All you have to do is put R as 1 in first and write out each term of the sequence. So we are, of the series should I say, we're summing from R is 1 up to 20 the expression 4R plus 1. So let's put 1 in first. 4 multiplied by 1, I might write this out, 4 multiplied by 1 plus 1, that's the first term. Then we are adding 4 multiplied by 2 plus 1, and so on. We are adding 4 multiplied by 3 plus 1, and all the way up to when I put 20 in, plus dot 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 dot, 4 multiplied by 20 plus 1. Now, therefore, we are summing up 4 multiplied by 1 add 1 is 5, plus 4 multiplied by 2 add 1 is 9, plus 4 multiplied by 3 add 1 is 13, plus dot dot dot, all the way up to 4 multiplied by 20 add 1 is 81, right? And we can go back to our SN notation, can't we? We know A is 5, clearly. We know D is equal to, it's going up in 4. And how many terms in the sequence? Well, you put 1 in, 2, 3, up to 20. We know that N is 20. So we could work out S20, which would be the sum of this. And that would be, let's just state Sn first of all, as always, N over 2, 2A plus N subtract 1 multiplied by D. So that would be 20 over 2, 2A, which would be 2 multiplied by 5, plus N minus 1 times D, that would be 19 multiplied by D, D which is 4. So S20, 20 over 2 is 10, 2 times 5 is 10, plus 19 multiplied by 4 is clearly 76, because 20 multiplied by 4 is 80, like that. So this is 10 multiplied by 86, so S20 would clearly be 860. And that is the sum of this. Okay, last example, a slightly different twist. It says, for what value of n, they don't tell you how many terms you have, would this sum add up to 0? Let's convert this sigma notation into series written out notation, because we could say our A, our D, and we could do some work with that. So we're summing 1 to, not 14, mistake, we're summing 1 to n of 100, take away 4r. So let's put 1 in. 100 take away 4 multiplied by 1, that's the first term, plus 100 subtract 4 multiplied by 2, plus dot 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 dot, and we don't know about the last term. So this is clearly 96, this thing's 96, plus this would be 92 plus dot dot dot. Right, so we know this is Sn as well. Another way of writing this is Sn. So we know A is equal to 96. We know that D, the common difference, is negative 4. And we don't know N. But we do know a formula for Sn. Sn is equal to N over 2, 2A plus N minus 1 D. And we know that the sum to N, they're telling us the sum up to this number N that we need to find is 0. So we could try and solve the equation 0 equals, don't know N over 2, must still write it, 2A, 2 multiplied by 96, plus N minus 1, I still don't know it, but I know that D is negative 4. So instead of writing plus negative 4, I'm just going to write negative 4 here and write negative 4 like that. Okay, I could double both sides to get rid of this divide by 2, and timesing this by 2 would still be 0, so 0 is N. 2 multiplied by 96 is equal to 192, and I'm going to expand this bracket, negative 4n plus 4. So 0 is therefore equal to n. 192 plus 4 is equal to 196 minus 4n. So we've got two things equal 0. Either n is 0 or 196 take away 4n is equal to 0. 196 is therefore equal to 4n, and divide both sides by 4. That gives us that n is equal to, must be equal to 49, I think. Is that right? N is equal to 49? Yes, n is equal to 49. So, what value of n would work? Well, not 0, because that doesn't make any sense. We're not counting that one, so we're just going to ignore. So, n would equal 49 is our final answer. And we are done for sigma notation. Hope you found that video useful. Thanks for watching.